This video will cover transition matrices for 3-state Markov chain situations. Now again, we can't do the entire Markov chain yet. What we can do is take survey data and turn it into a transition diagram or a transition matrix, and then talk about that data after each transition. So in this case, we have another example. I wrote this one as well, so it works out rather nicely for us. In this case, we have a town in Georgia which has 3 burger joints: Alfonso's Fine Dining, Burger Queen, and Carrie's Burger Hut. We'll use A for Alfonso's, B for Burger Queen, and C for Carrie's Burger Hut. A survey was conducted of local patrons on which burger joint they would try the next time they went out to eat. At Alfonso's, 61% of patrons said they would return to Alfonso's, 18% said they would go from Alfonso's to try Burger Queen, and the rest said that they would go from Alfonso's to try Carrie's. Now it is important that we figure out what that number is. So we would take the 100%, subtract the 61 that are returning, and subtract the 18% that would be trying Burger Queen. That would leave 21% going to C from A. Okay, at Burger Queen, the same survey is run. 38% of those patrons said they would go from Burger Queen to try Alfonso's. 31% said they would return to Burger Queen a second time, and the rest said they would try Carrie's. So once again, we're going to take the information provided to us, subtract 38% and 31% from 100, and figure out that that leaves 31% going to C, and that would be from B. And then finally, the same survey run at Carrie's Burger Hut says 21% of the patrons there would be going from Carrie's to try Alfonso's. 35% said they would be going from Carrie's to try Burger Queen, and the rest said they would return to Carrie's. So once again, we're going to do 100 minus those two numbers to figure out that 44% return to C. So once again, there's two different ways we can represent this data. We can do it as a transition diagram or as a transition matrix. So we'll start by writing the information out as a transition diagram. This is a 3-state complete transition diagram. So we're going to represent our 3 burger chains with circles with the letters A, B, and C. A could return to A could go to B, or A could go to C. B could go to B could go to A, or B could go to C. C could go to C could go to A, or C could go to B. This is our basic blank 3-state transition diagram. It shows every possible movement. Now what we need to do is we need to label this graph with the information from the survey. So according to the survey, 61% of the people who ate at Alfonso's said they would return to Alfonso's. So we would label that edge with 61%, 0.61. 18% said they would go from A to try B. So we would put 0.18 on the edge that goes from A to B. And that meant that 21% of the people at A would be trying C. So 0.21 would be the label on that edge from A to C. For Burger Queen, 38% said they would go from B to A. So we'll put 38% as 0.38 on that edge. 31% said they would return, so we'll label the loop with 0.31. And the rest would be going to try C. That is also 0.31 on that edge from B to C. Carrie's Burger Hut, 21% of the patrons said they would try Alfonso's, so this edge has a weight of 0.21. 35% said they would be trying Burger Queen, so we would label that edge with 0.35. And that meant that 44%, or 0.44, would start at C and go there again. Now that same data can be shown in a matrix. This matrix is called a transition matrix. We've discussed this already. And we're going to use the letter U to represent that matrix. Now in this case, this is a 3-state transition matrix, meaning this will be a 3x3 matrix. We'll have 3 rows representing what company we are starting at, and 3 rows representing where we're going to end up. So we're going to take that same data and we're going to put it into this graph. The people that start at A and end at A is this loop. So 0.61 goes in the upper left. Starting at A and ending at B, that's this edge, is 18% or 0.18. And starting at A, ending at C is the 0.21. Starting at B and ending at A is 0.38. Starting at B and ending at B is 0.31. And starting at B and ending at C is also 0.31. For C, starting at C and ending at A is 0.21. Starting at C and ending at B is 0.35. And starting at C and ending at C is the 0.44. Now again, what this transition matrix is showing is it is showing the probability that a person chosen at random who works at A would go to one of the 3 places, etc. So notice that the rows still add up to 1. Each row will always add up to 1. If it doesn't, you've messed something up. Now, just like we did with 2x2 matrices, 3x3 matrices, this matrix can be used to make predictions as well. So let's look at what we would do with that. It's going to take me a minute to transition it, I think. Actually, let's see if I can just copy and paste it. That'd be the fastest way to get it there. Of course, it has to decide it wants to do that first. Come on, computer. Figure it out. Okay, definitely have the entire matrix. So, if we want to know what that transition matrix looks like after one transition, it's going to take me a second to get this where I want it. Okay, so here we have matrix U. Give me a second to get this cleaned up here. We don't need A, B, and C. We don't need those labels. Okay. This is matrix U. So what we would do is we would take matrix U, and if we want to know what it is after one transition, that would be the matrix U squared. So we would multiply this matrix by U again to turn it into U squared. So 0.61, 0.18, 0.21, 0.38, 0.31, 0.31, 0.21, 0.35, 0.44. And again, this is matrix multiplication. So we'll end up we'll put our answer up here, but we're going to do the work down here. Okay? So row 1 times column 1 would be 0.61 times 0.61 plus 0.18 times 0.38 plus 0.21 times 0.21. That's this number times that number, plus the second entry times the second entry, plus the third entry times the third entry. Then we would do row 1 times column 2, which is 0.61 times 0.18, plus 0.18 times 0.31, plus 0.21 times 0.35. Now keep in mind that the rows in our answer will also add up to 1. So our third entry, once we have the first 2, we could add those together and subtract them from 1 to get that last entry in the row. So we don't necessarily need to write out the third entry. We can just subtract the 2 that we've already come up with. So then we do row 2 times column 1, which would be 0.38 times 0.61, plus 0.31 times 0.38, plus 0.31 times 0.21. Then row 2 times column 2, which is 0.38 times 0.18, plus 0.31 times 0.31, plus 0.31 times 0.35. And again, the third entry in that row will be the rest of the 1. Then we'll do that one last time with row 3. Row 3 times column 1, which would be 0.21 times 0.61, plus 0.35 times 0.38, plus 0.44 times 0.21. Then row 3 times column 2 is 0.21 times 0.18, plus 0.35 times 0.31, plus 0.44 times 0.35. And once again, the final entry in that row will be the rest of 1. So then we're going to go and feed these to the calculator to get the actual decimals out. And this is going to take a considerable amount of legwork on your part. You know what? That's called a high school level class. Okay, we need to put in the work. So let's see. This first entry would be 0.4846. Just a quick double check to make sure I didn't screw that up. Nope, it's good. Okay. Then 0.61 times 0.18 plus 0.18 times 0.31 plus 0.21 times 0.35 is 0.2391. Then subtract both of those decimals from 1 tells us that the third entry has to be 0.2763 so that it will add up to 1. Our second one, we're going to start on that row, 0.38 times 0.61 plus 0.31 times 0.38 plus 0.31 times 0.21. That is 0.4147. Row 2 times column 2, this set of numbers here. Oops. This set of numbers here. I'm going to put that in next. 0.38 times 0.18 plus 0.31 times 0.31 plus 0.31 times 0.35 is 0.2730. And then we're going to subtract both of those from 1, which is 0.3123. And then we'll do the same thing for the third row. 0.21 times 0.61 plus 0.35 times 0.38 plus 0.44 times 0.21. Oops, I messed something up there. I missed a decimal point. Which is 0.3535. Same thing for the second entry, 0.21 times 0.18 plus 0.35 times 0.31 plus 0.44 times 0.35, which is 0.3003. Subtract both of those numbers from 1, and our final entry would be 0.3462. So this would be our answer. What is u squared? What is u after one transition? It would be that matrix right there. That does it for transition matrices. Hopefully at this point you feel confident that you could turn survey data into a matrix or a diagram, and that you could tell me such a matrix after 1 or 2 transitions. And for a 3x3 it will only be after 1 transition. Thank you for your time.